Afternoon, everyone. Welcome to another edition of Tools of the Trade. I'm Marshall Campbell, Sales Manager at Marshall E. Campbell Company. With us today is Zach from Panduit. He's going to be going over the Verisafe absence of voltage tester. During this presentation, if you have any questions, please type them in the chat. We will address them right away, or we'll wait for a pause or till the end of the presentation to answer any of those questions. Thanks again for joining us today. We really appreciate it. That being said, Zach, take it over. All set there, Zach?
Okay, can you hear me now?
Yeah, we got you.
So sorry about that. I'm running like a chicken with my head cut off right now. We had a bunch of hail and a tornado come through about 10 minutes ago here in Georgia. So
I hope everybody's all right.
I think they're always reactive with these. So let me I apologize for the slight delay here. I am going to is the audio quality coming through all right? If not, I'll switch to my phone.
No, everything sounds good.
Okay, awesome. Let me share my screen then, and we can go ahead and get started. Alrighty, well, good afternoon, good morning, everyone. My name is Zach Ganster. I am the product manager here at Panduit. Let's see. And there we go, perfect. And just want to talk to you guys today about the Verisafe absence of voltage tester. Any questions that come through, I believe you can ask those in the chat. And Marshall, if you want to stop me at any point, feel free. But what I'm going to do today, it's a little bit different. I'm going to be going through the just the overview on what the Verisafe absence of voltage tester is from Panduit. And then I'm going to switch from the presentation mode over to my webcam video where I have a demo set up and kind of let you guys see what this Verisafe does in real life, this in lieu of not being able to be there in person. This is kind of our best alternative. And then I'll wrap it up with some presentation as well. So I'll try and get through the PowerPoint content as quickly as I possibly can so we can focus on more of the quote unquote live demo. And then I will try and save some time at the end for questions as well. So when I'm talking about absence of voltage testing, traditionally, this is the process that companies across the world really do, and specifically in the United States and Canada. So on the bottom here, you kind of see this process. It's laid out in the NFPA 70E, and where if you're going to go in and perform some sort of work, electrical work, you would first start by putting up your barricades, letting the affected individuals in that area know. You'd isolate and de-energize that supply and apply all your locks and tags. You'd select and inspect and put on whatever PPE you would need for that specific piece of work. And then you'd test that tester, that portable tester on a known voltage source to verify that it's operating correctly. Then you'd go back to your panel where you're performing your work and verifying a de-energized condition, and you test that equipment phase to phase, phase to ground. And then finally, you're going to go and retest that tester on a known voltage source. So in addition to having a lot of different steps and different things that you're having to remember to do, it's also very time consuming to go back and forth and to make sure your portable meter is working, things like that. So it's what we've seen over the past 10, 15 years is that this process is complex and a lot of times it's led to failure. One of the key cogs of those failures have really been within the portable testers themselves. So there's a lot of different things when you're leaving it up to the human. You're having risk in terms of either steps being missed. You're inevitably exposing them to hazards by having the door open. There's the possibility of human error, inability of access to a known voltage source, and then other things like damaged probes, misinterpretations of settings, and also something that's becoming more and more common is having a lack of contact with the conductors or the ground. So Panduit kind of took a step back, and we've been looking at issues like this in the electrical safety world for some time now, and started asking ourselves some questions. Can we make design features that make sure that each step of this process is completed? Can we somehow make it more efficient, or can we ultimately reduce the exposure to the user of some of these hazards that they're coming in contact with every day? And that really led to the Verisafe absence of voltage tester. So what that is a permanently mounted tester, and you're using that to verify that a circuit is de-energized. So what you have in a pictorial view here is on the front of the panel, you're going to have a circular yellow indicator. That's going to be the front-facing portion of this device, and it allows you to test before that door is open and make sure that you have 0 voltage inside of that panel. And then behind the scenes, you've got a system cable that runs from the indicator module to the isolation module, which is that black box there. That black box is keeping that hazardous voltage away from the door, and then it's also the brains of the absence of voltage test. And then you're ultimately hardwired to each phase and ground to wherever you're going and testing for absence of voltage. So overview of the Avt operation, and I'll go through this on my webcam here in a minute. But the red LEDs indicate that hazardous voltage is present. And that's typically when the upstream power is on. These red LEDs are run off of your system power. So when the power's on, those red LEDs are on. And then when the upstream power is turned off, those red LEDs will typically no longer be illuminated, but that does not guarantee voltage absence. What needs to happen is you need a push of a button to initiate that test. And what that button push is going to do, it's going to start flashing that yellow triangle. You're going to see the process. It's checking phase to phase, phase to ground. It's checking connectivity. It's checking itself, and it's checking a known power source to make sure that everything is functioning correctly. And if you have under 3 volts AC or DC, you're going to get a green LED indicating that absence of voltage is confirmed. So why this is really important. The big thing that happened back in the 2018 edition was that in the NFPA 70E and in the CSA, now the CSA Z462, which is the Canada standard for electrical safety in the workplace, they wrote in an exception to step 7, which is the step inside of Article 120.5, which is that process for establishing and verifying electrically safe work conditions. So that process I walked through in the first slide. This step 7 is talking about that test instrument and testing phase to phase and phase to ground and making sure that it's operating satisfactorily. The NFPA 70E wrote an exception to that step to allow for an adequately rated, permanently mounted absence of voltage tester to be used, provided that it meets the following criteria. This is the actual coming out of the standard right here. But what it allows you to do is in lieu of a portable test instrument, you're now able to use a permanently mounted absence of voltage tester. And so if we compare that per NFPA 70E, you're going to see the 2 different processes here. So on the top, the portable tester, which we've already walked through that a couple times. And then on the bottom, you have the absence of voltage testers, or the Verisafe. And you see with that push of the button before the panel is even open, you're testing the tester, you're verifying the installation, you're checking for voltage, you're verifying the installation again, retesting the tester, and you're getting a result. So the 2 key points here is that not only are you doing it before the panel is open and you're exposing yourself to potential hazards, you're also doing it in a fraction of the time, where that absence of voltage test on the permanently mounted process is less than 10 seconds to complete. Compare that to the manual process of finding all your PPE, testing the tester, walking around. You're gonna save a lot of time. Typically, we've seen it be about 10 to 20 minutes to complete that process with the portable tester. And this just shows a good image of the two test processes on the same exact panel here. So on the left, you've got the traditional method. You can see the PPE is on, the panel is open. They're assuming that it is energized until they've verified that it is in a de-energized condition. And then on the right here, you're using a permanently mounted AVT. You can see that you're getting that absence of voltage confirmation before the door is ever even open, so you're not exposing yourself to any hazards inside of that panel. So terminology matters when we're talking about whether it be portable test instruments or permanently mounted products. So the big thing I want to call out here on this slide is UL 1436. And in the NFPA 70E and CSA Z462, the requirement for a permanently mounted absence of voltage tester is that it meets UL 1436. And that's all of the requirements for a product like Verisafe. Some of the high level requirements is that it has to have that connectivity test. It's got to be fail safe, so that's a functional safety rating of SIL 3. And in addition to a lot of other requirements, like it has to have a green LED and a dedicated green LED to eliminate any confusion. And so that UL 1436 is extremely important. This product is the only product on the market that meets that UL 1436 listing. So other products, while they have good uses, whether it be for warning of hazardous voltage or troubleshooting, they do not meet the requirements in NFPA 70E to replace that portable test instrument. And the equipment with absence of voltage tester, just to give you guys a flavor for where we're seeing adoption and where customers are installing these. Our top three would be control panel, motor control center, and switchboard or switchgear applications. Anything up to 600 volts AC or DC is a key application for Verisafe. But we have seen it in things like safety switches, transformers, package drives, bus ducts, things like that, disconnects. And it's suitable for new equipment, retrofits, and OEM installations as well. So we've seen it both installed on existing equipment and then also specified in and installed on new incoming equipment, whether it be from an OEM or like a panel shop or machine builder. So overview of the different products that we have today. We've talked about the absence of voltage testers, and then we've talked to, and that within that absence of voltage tester category, we have two main products. One, just a standard absence of voltage tester, and then we have another line of SKUs for Class 1 Division 2 hazardous locations. And then we also have on the bottom left here, a plethora of installation piercing connectors that are specialized for the installation of Verisafe. So one of the things I touched on is that there has to be a connectivity test. And the way that we achieve this with Verisafe is we have 2 sensor leads per phase. So that those 2 sensor leads per phase can be challenging to install sometimes. So we develop these installation piercing connectors that allow those that have 2 openings for each sensor lead per phase. So it makes it a standardized installation. It eases the strain on figuring out where to install these. And overall, we've seen a lot of adoption just on 2 fronts, making it standardized and then also making it more efficient to install. We also have a retrofit enclosure. That's exactly what it looks like. It's a little 8-inch by 8-inch box with Verisafe pre-installed. And that retrofit enclosure is really used for customers who may not have space in their panel to install. So you just install this next to that piece of equipment, and then you'd run your conduit in and terminate the sensor leads, and then you're able to test for absence of voltage in that panel. And then finally, we have an access control kit. I'll talk to this in the webinar or the webcam portion because my demo actually has an access control kit installed. But what we have is we actually have output contacts on the Verisafe device, and that's part of that SIL 3 functional safety rating. And what we've seen customers doing is those output contacts will remain open, and then they'll close when the green LED is illuminated. So it's an additional layer of safety and security where that panel will remain locked until you get that absence of voltage test, and then the panel unlocks and they're able to perform their work. And I think at this point, yeah, I'm gonna stop sharing here, and I'm gonna see if I can get my webcam up and running. So bear with me 1 second as I pull this control panel back out. So let's see here. Make sure the right webcam is up. I think I can switch. This is not the one I want. Hang on 1 second. I have two connections here. So here we go. All right, and let me pull this back. Everything got shifted when I had to run out this room here for that tornado warning. So give me 1 second here. My apologies for this. Normally I've got this set up and ready to go. And hey, Marshall, I'm just going to confirm that you guys can see that on the on your computer screens here.
Yes, Zach, I can see it.
Perfect. All right, so this is the Verisafe Demo. I'm going to go ahead and turn it on. You can see on the side of this demo, I'm just running it off of a standard 120 volt AC power, but we have it wired to show a typical 3-phase application here. So if you see the red LEDs are illuminated when the power is on, and that fan is illuminated as well, just to kind of show you that there is voltage in this panel. And some quick things before I move forward, you kind of see these are the insulation piercing connectors taps that you see, those black boxes there. And you can kind of see the 2 sensor leads per phase, the brown and the orange and the yellow. So that would be a standard install. Those can be, the Verisafe sensor leads can be installed on the line side or the load side of a disconnect. It really is where you're testing for absence of voltage. And so you have your indicator module here. You got your isolation module up here. It's panel mounted in this demo to save a little bit of space and depth because it is a smaller box compared to a typical enclosure. But 95% of the time, customers are installing these on a DIN rail, and it does have the DIN rail mounting option. So what I'm going to do is I'm just going to press this button here, and you're going to see that yellow triangle flash, and you can see how quick it is. Obviously, since power is on, it's not going to give me the green LED. You see the 2 flashes. So when it goes solid, it's actually going to let you know what's going on. So as we walk through a couple use cases here, you're going to see a couple different flash codes. So that 2 flash code means, hey, I have voltage above 3 volts AC or DC on this system. Obviously, since the power is on, you're going to get that 2 flash code every single time. What I'm going to do is I'm actually going to turn off this disconnect here, and I'm gonna run that test again. You're gonna see that fan is still spinning, and that's actually inducing a DC voltage into the system. So I'm not gonna get the green LED yet. So just to show, it's gonna check for AC and DC voltage, and when that fan was still spinning, it's giving above 3 volts into that system. So if a motor is powering down, or you've got some sort of drive still inducing a DC voltage or a battery bank, Verisafe is going to be able to detect that and alert you of any residual voltages that are still bleeding off. So now that fan has stopped spinning, I'm going to run this test again, and you're going to notice this time you're going to get the green LED, and that indicates that there's no voltage under or over 3 volts AC or DC in the system, and you're able to go in and perform your work safely and quickly. One other thing that we did talk to, or I guess there's 2 other things I wanted to mention here, is the connection test. So when Verisafe is running that test, when you press that button, it's actually verifying to make sure that these sensor leads are still connected to the conductors they were installed to originally. So what I have down here is I have a couple switches, and I'm going to flip one of these switches off, and what that's doing is it's simulating one of those sensor leads becoming disconnected. So I'm going to run that test again, and you're going to see this time, now that I've disconnected one of those sensor leads, it's going to give me a 4 flash code error, letting me know, hey, I can't verify that I'm connected where I'm supposed to be connected. So you're going to have to go in and understand what exactly is going wrong. That could be misinstallation. Something could have happened when you threw the disconnect. Maybe an arc had happened and it blew off a sensor lead. It's going to let you know if something went wrong in that panel. So it's just an additional fault code that's going to let you know before you ever open the door what to look for and warn you of any potential hazards. So what's running this test? I've turned off the power. We get that question a lot. And what it is a 3.6 volt lithium battery that you can kind of see in this battery tray here. And that can be changed at any time when the power is off or on. This whole section right here is IP20 touch safe, and there's only 5 volts coming to this Verisafe when it is powered up. So that battery lasts 5 to 7 years and is able to be changed at any time. So I'm going to go back and flip my sensor lead back on. The 4 fault codes that can happen is low battery. That'll give you 1 flash. If there's more than 3 volts AC or DC, it'll give you 2 flashes. If it's a connectivity failure, it's going to give you 4 flashes. And then if there's any sort of hardware failure inside of this black box here, you're going to get other flash codes too. So it is a fail-safe device. If components are to fail in that system, it's not going to fail with the green LED. It has to have 2 isolated incidents at the same exact time to ever give you that green LED. And that's part of that functional safety rating. So the last thing I want to show is I want to show the access control. So you notice up here, we have this electronic latch installed, and you can see here that you've got the output contacts on the isolation module, and you've got some wires running there. So what those wires are doing, those outputs are going to close when the green LED is illuminated. And what I'm going to do is I don't think you can see it on the screen, but there's a latch up here in the top corner of this demo. I'm going to unlatch that so there's nothing really holding it back. I still can't open this panel though until I get the green LED. So I'm going to run that test again. And this time, when I get that green, you're going to notice that the door is unlocked and you're able to access that panel at that time. So that's just an overview of the actual demo of the Verisafe AVT. I'm going to switch back to the webcam real quick. So let me show my screen here. Oops, lost it. Hang on one second. And we'll wrap up here in the next 3 to 4 minutes. So. All right. So just an overview of the features and benefits of the Verisafe AVT. It's really both a safety and a productivity play, as you've probably recognized by now. You're going to have that improved safety and risk reduction by being able to test before the door is open, and you're taking a lot of the human error out of the equation when you're using an automated process like this. You have that UL 1436 compliance, unlike any other product on the market today. You're getting reliable results every single time you press that button. With a portable process, you never know if you're following all the steps to the right degree, and you may have steps missed or skipped along the way. You're simplifying that process for your safety program. So instead of having to remember all those 7 steps, you're able to press the button and it's doing all of those steps for you in one press of a button. You're able to install it across really anything up to 600 volts AC or DC. And that's ultimately you're getting increased productivity where you're reducing your downtime. You're not waiting on that de-energized state. You're getting that real time in 10 seconds, able to get in and out of panels quicker and keep your processes up and running. And just a quick overview of the AVT adoption to date. So we launched this product in 2017. It was patented around 2018. We talked about that NFPA 70E exception getting written into the standard back in 2018. And then we've really seen between 2018 and 2020 is that the NFPA 70E was really a catalyst for this, but we've seen a really broad adoption across a lot of these larger companies. So we did at the end of 2020, kind of looked at who's using this. And of the Fortune 100 industrial companies, we've seen about 42% of those companies either actively specifying it throughout all of their plant floors, or looking into it and trialing it, demoing it, things like that, and looking to convert their safety programs over. And then we're just seeing continued adoption in the standards committees, where it's spread to CSA Z462. It was clarified in the 2021 update to add in that UL 1436 standard. And we're looking at IEC standards, things like that, as we move forward and as this technology becomes more prominent in the workplace. So good resources. The Verisafe landing page is a really good one. It's panduit.com/Verisafe. Got all of our videos. It's got all of our collateral, whether it be white papers or spec sheets or FAQs. So be sure to check that out. We also have an AVT mobile app, and in that mobile app, we have a virtual demo that you can play around with. It's interactive. We've got an FAQ sheet that's searchable, and then we also have an ROI calculator. So if you want to look at, what if I put 20 of these on my machine control panels that are accessed once a week, what's my ROI to invest in Verisafe in terms of the time I'm going to save? So that's a really cool tool to have, and then we also have all of our resources in that mobile app as well. At that point, I'm going to wrap it up. Got a couple minutes left. I know we started a couple minutes late, so I'll open it up for any questions from anyone on the call today. And I'm gonna try and pull up my chat screen here, see if I can see anything that's coming through.
Doesn't look like we have any questions today, Zach. I think it was a pretty good presentation. The one thing that I'll mention, we're seeing a lot of this take off with customers that industrial settings where they get new people on, or there might be turnover, or they're trying to come up with a system to keep their people safe. You think of how easy it is for them to, put a label right on this button and tells them exactly how to operate it and what the faults are. So now you've taken a lot of that error out of their hands, where they're doing the dead live testing. They don't know maybe how to use a voltage meter correctly. They're not going through their steps. This would be right in front of them that they can easily read to go through those progressions. So that's where we're seeing some good traction in this, and customers taking advantage of it.
Awesome. Yeah, exactly. Same here, Marshall. So good comment.
Otherwise, I think that's it. If there's no other questions, thank you everyone for joining today. Thank you, Zach, for putting this on. Really appreciate it. It was a good demo.
Thank you, guys. Have a good rest of your day.